An AI agent does not have to be malicious to cause damage. Sometimes the dangerous failure is simple. It takes the same action twice. Two tickets, two messages, two priority changes, two workflow triggers. In this video, I'll show you how to design AI agents so they act once, verify the result, and do not repeat the same side effect by accident. Here is the production failure nobody likes talking about. The agent does the right thing, but it does it twice. A timeout happens after the ticket was created. A webhook retries, the agent loses track of state. The approval button gets clicked again. The job restarts halfway through. Now the system has duplicate tickets, duplicate comments, duplicate notifications, or duplicate changes to a real system of record. That is not a prompt problem. That is an execution design problem. Duplicate actions usually come from 5 places. Retrace after timeouts, webhooks that deliver the same event more than once, jobs that restart without remembering what already happened, agents that do not check current state before acting, and tools that create side effects without a stable action ID. In normal software, we call this an idempotency problem. In AI agent systems, it becomes even more important because the agent may be deciding what to do while the workflow is also deciding whether to retray. Delta idempotency means the same request can run more than once without creating a second side effect. If the agent asks to create a ticket for finding ABC on asset 123, the system should be able to say that action already happened. Here is the existing ticket. Do not create another one. The goal is not to stop every retrie. Retries are useful. The goal is to make retries safe. The first control is an action key. Before the agent touches an external system, create a stable key for the intended action. That key should include the workflow, target object action type, and version of the decision. For example, vulnerability triage asset 123, finding ABC, create remediation ticket. If the same key appears again, the system should not blindly execute again. It should look up the previous result and return it. The second control is a state check. Before acting, the agent should ask, does the target state already exist? Is the ticket already open? Has the priority already changed? Has this user already been notified? Is there already a pending approval? This matters because the real world can change between planning and execution. The agent may have been right 5 seconds ago, but before it acts, the system still needs to check the current state. The third control is a lock or lease. If two agent runs to see the same event at the same time, both might decide to act. A lock says only one worker can execute this action key right now. A lease says this worker has the right to act for a short window, then the lock expires if it crashes. This prevents two copies of the same agent or two retries of the same job from racing each other into duplicate actions. The fourth control is separating planning from execution. Let the agent produce an action plan first. Then a deterministic executor checks dedupe rules, permissions, state approval, and locks before any side effect happens. This is safer than letting the model directly call every tool. The agent can recommend, but the execution layer decides whether that recommendation is new, allowed, and safe to run. Approval gates need duplicate protection too. A human should approve a specific action once, not approve a vague intention forever. The approval record should include the action key, target object, exact change reviewer, timestamp, and expiration. If the same approval is replayed later against a different object or a changed state, it should not automatically execute. Approval is not just a yes. It is a yes for this exact action under this exact context. Imagine a vulnerability triage agent. It sees a critical finding on an internet-facing asset and creates a remediation ticket. But the ticketing API times out after creating the ticket. The workflow retrays without idempotency. The agent creates another ticket, then maybe another. Now the security team has duplicate work, duplicate SLAs, noisy metrics, and confusion over which ticket owns the fix. With action keys, the second run checks the ledger, finds the first ticket, and links back to it instead of creating a duplicate. Here is the checklist. Give every external action a stable action key. Store action attempts in a ledger. Check current state before execution. Use locks the leases for concurrent runs separate agent planning from deterministic execution. Make approvals specific and expiring. Return existing results when a retry repeats the same action. Alert when duplicate attempts spike. If you cannot answer whether an action already happened, the agent is not ready to act autonomously. The safest AI agents do not just make smart decisions. They make controlled changes. A production agent should be able to say, I planned this action, checked that it was new, locked it, executed it once, verified the result, and recorded the proof. That is how you stop duplicate tickets, duplicate messages, and duplicate workflow triggers before they turn into operational noise. If you want more practical AI agents for cybersecurity and automation, subscribe